All right. So let me go ahead and mute my video capture device so we can look at the calendar here. All right. So this class seems a bit, I don't know, not antsier than normal, but basically more. This class seems to want more than previous years to know the exam date. So at least for the first exam, I'll be able to tell you those exams. So first off, I've decided that we're going to give them in lab, okay? Which means that based on when your lab is, that's when you'll take it. So that will start October 1st. So if you have lab on October 1st or 2nd, I don't think we have any labs on Thursday. So your exam, depending on what your lab section is, will be on the 1st, the 2nd, the 4th, or the 7th. Okay? So the Monday, people with the Monday, because the way the lab schedule works, right? Where the Monday, because of the holiday, the Labor Day holiday, the people who had a Monday lab, they didn't have a second lab, so that got pushed to the third week, right? And that all evens out at the end of the semester when with that hanging Monday, okay? So I like to say, for this class, imagine that the week begins on a Tuesday. So beginning on October 1st, 2nd, 4th, or 7th, that is when your exam is, okay? So I will send out the practice exam right now, actually. I know we're all still learning that material, but that's just simply because I like to give the practice exam early so you know what to target. And that also means on the 26th, I will go over that practice exam for the entirety of the class. I will spend all class going over each answer. There will not be an answer key. I will just simply go over each question in sequence on the 26th, which I find to be much more useful. Make sense? Okay. So let's go ahead and then put my face back on this and now send out an announcement. Okay. Because, there's a ton of people who aren't here, and so we might as well send that out. I always like to do this. I always did this when I was, be it an undergraduate student, and now on the other side where I use brackets and then the course name, just simply because that made it very clear to whoever was reading it what class we're talking about, and that's a very useful practice to do. Exam 1 date and practice exam. Exam 1 will be in your 6th lab. That means, depending on what you signed up for, and what lab you signed up for, your exam will be on 10-1. What were those dates again? 10-1, 10-2, 10-4, 10-1, 10-2, 10-4, and 10-7. And then I have to say this. This does not mean you get to choose which of those dates to take the exam. You must show up to the lab section you signed up for, because otherwise there's not going to be enough space for people to go. Okay? Attached is the practice exam. Insert. So, and this is the way it works on my end. Course documents. I believe I still have practice exam 1 here. Exam 1 practice. Boom. There it is. Because, now like I said, this practice exam is essentially, I made twice as many questions as I needed to. Okay? And since there's twice as many questions as I needed to, I took half of them and tossed them into a practice exam. The practice exam, in fact, has more questions than the actual exam does. For instance, here on the practice exam, you have 10 expression questions, Instead, on the actual exam, I have 5, and they're multiple choice questions. So here they are, hey, give me the answer and fill in the blank with the answer. Instead, for the actual exam, there's 5 of those, and there's multiple choice. Make sense? So here we have basic computer concepts in history, so stuff from lecture 1. They're fairly straightforward questions. Expressions, that'll be worth about 10 points on the exam. Some questions that involve, hey, what are the values? Do you understand how assignment statements work and things like that? Don't worry, I never remember if I put this on the exam, the true or false questions, but they're worth going through. And then let's see. And yes, slice questions, because you are going over sequences. So slicing, by the way, is new to everybody, depending on whether or not you're taking this is your first class, or you have some prior programming experience, because slicing notation is not found in the other kind of beginning programming languages like Java or C. Slice notation, though, is extremely awesome because of how concise it can be. And then complete the function. I don't make you write a lot of code. In fact, most of the points are in questions like this. Draw the result of the turtle program below, where I give you a turtle program and ask you to, do that. And then another common thing I might do is this is actually word for word on the exam, except the code is slightly different. Here, I ask you, hey, draw what the program does. And then here I add another argument that changes the code, and I don't ask you to draw it again. I ask you, okay, what effect does that argument give me, right? What changes does that give? Then draw the result again. Oh, we did this in class. And then here's another one where I say, hey, here's some code, here's the output, draw this. Although, again, the questions on the exam are, I try to make the practice exam questions more challenging. I try to make it the same, and some questions it's more challenging. There's even extra, you can tell if a question is extra practice if I give it 0 points, in which case, why should I not give you extra practice? Yes? What? I wish somebody had mentioned that earlier, geez. Normally just... Oh gosh, here I'm gesturing at stuff and I think I just did a dump. Ta-da! I totally made a dump. All right, so here I am looking at these things and talking and gesturing on the laptop as though you can see me, and you cannot. So here we go. Ooh, what was that? All right, so yeah, let me go through this. Sorry. First part, you'll have, like I mentioned, basic history and concepts. We have these expression questions. There'll be multiple choice on the exam. X, Y, and Z, so basically understand what this code is. Understand what this, Boolean questions. Slice notation. We're going to go over sequences today. And a lot of, this was what I was talking about, where this is pretty much on the exam itself, just a slightly different function. And then this one, draw the result of the turtle below. Here's a picture, draw it with using the turtle. Here's that extra credit question I've said. And I said use the draw square function, because notice that this is a bunch of squares. And this is also a bunch of squares. I don't think I have equivalents on this of this on the exam, confundus and confundo. They're just meant to be, they're meant to get you to think. And the nice thing about this code, when it asks you what is the output, even though it's on paper on the exam, you can't check it, during the exam. But like for the practice exam, you can totally check your answer. And then there's a ton of extra practice over here. on the back. And if you can knock out this extra practice on the back, you're probably going to have no issue on the exam whatsoever. So, but I will be going over this next Thursday, so just give yourself some time. Give yourself about 2 hours to do the exam, and to, after studying or give yourself about 2 hours, because you will have 2 hours on the actual exam. The actual exam itself will be shorter and less difficult, but I do try to, or at least that's my opinion. Students may have different opinions. All right. So with today's exercise, we're going to go over Kiva, which means, we're going to go ahead and go to Module 4. We are going to go and click on Thursday. We will work on Project 6 from the book. Computing Statistics with Kiva. Okay, Kiva. So Kiva is a micro-lending platform. It's a charitable organization. The idea here is that you lend money out, okay? As small of amount as $25 in the form of a very tiny loan, which gets compiled with other people's loans, okay, for various purposes, be it humanitarian, kind of rebuilding efforts, be it small business startups, be it food security, be it education, okay? And then the idea here is that these people, they are loans as opposed to donations, so the people, they pay back the money, and then that money gets lent, and then, so say I lend out $25 to help pay for somebody's tuition, okay? Then eventually that money gets paid back to me, and then I loan out that money again, essentially. So that $25 keeps traveling around. Okay? So, great organization, they do great things. And as you might imagine, any organization that basically deals with finances has to keep track of the finances. So, any organization that ends up touching a lot of people, and you got to keep track of those things, you generate a lot of data. So what we're going to see is kind of some basic data science kind of things, or the tasks of data science. Now, the data science is the one sentence kind of definition of data science is, well, for computer science, we said that was the study of algorithms. Data science is the continuation of statistics through computer science, essentially. That is the one sentence kind of summary that I really like about it. And part of the big thing about data science versus statistics is being able to not just do a bunch of computing of the data, but also being able to take data from these large databases and sift through them and make the data sets yourself, as well as take the data sets and then analyze them. Okay, so here we have, I think, 50 entries from the subset of it. They mentioned that that the normal data, the actual data set that they were working with Kiva, had 1.4 million rows, and that's a bit much to load into your web page, so we're only doing 50. Okay? It's just like an Excel table here, only it's stored in text. I'll show you how it's stored in just a second. But here we've got ID. Now that's essentially every kind of transaction or loan has an ID. For purposes of statistics, though, the ID is not going to be useful. We're not really going to use it at all. Loan amount, that's fairly self-explanatory. The loan amount is the amount of money that was loaned, right? Or the amount of money that loan has. Country name, where that money is going to. Status funded. They're all funded here, so again, we can kind of ignore that. Time to raise, I assume this might be in seconds, but it was probably but that looks like the amount of time it took to raise the loan. And then number of lenders total, right? So this $500 loan, $500 was put together from the various donations of 18 different people, right? Each of which probably contributed a different amount. That's probably stored in a separate table, but that's, data but that's interesting for us over here. For instance, this $150 loan was secured by one person. And this $1,525 loan was one person. So, so when it comes to analyzing large data sets, Python is one of those tools. There's a couple different tools. R, which is a programming language. For some reason, programmers, we love having single-letter programming languages. We have C, C++, C#. There's also D, and then there's F#, I think. And then there's also, well, now there, and R specifically is a statistical programming language. It's made for doing statistics. Python, specifically NumPy, N-U-M-P-Y, which you will not need to learn about unless you decide to do statistics for your final project. You know, that is one of the big tool, that is the other big tool for working with statistics and stuff. Okay, so for right now, what we're going to do is we're going to work with just these 50 items. And what they've done, okay, to keep the, is that for each code block, they've loaded these 4 lines in. Loan amount is equal to this. Country name is equal to this. Time to raise is equal to this. Num lenders is equal to this. Right? What is this? Well, all we have kind of done is that we've kind of kicked this table over and rendered it horizontally rather than vertically, right? So loan amount, $1,250, $500, $1,450, $200. Okay? $1,250, $500, $1,450, $200. Right? So it's in the same order. Make sense? And it would need to be because the first entry is $1,250 Azerbaijan with 38 lenders. $1,250 Azerbaijan, 38 lenders. Second one, and then the second one is El Salvador. Right? Now, hopefully you've had a chance to take a look at the videos with dealing with sequences. And if you haven't, it's okay, but there's just kind of but let me go ahead and run this. Okay? The way this works is that the reason we use brackets is that, like, for matrices, you would normally use underscores to kind of, you'd use subscript to denote when how to get something inside a larger set. Not there yet. So instead, here we use brackets. So print loan amount, printing out, asking to print out the entire thing. Sorry, asking to print out a list. Print out the entire list. But what if I only want to print the very first thing in it? You use the bracket notation. This is subscript notation. And you say 0 to get the very first thing. You say 1 for the very second thing. I don't think we need to use this. I forget if we have to use this today. I don't think we do. Oh, yes, we do. 4. 3. So you use subscript notation, right? Make sense? Subscript notation, the readings go over this, my videos go over this. So if you're lost, so if you get lost today, refer back to those videos. But so let's go. But basically, this thing has 50 items in it. Okay, those 50 items are put into slots. Okay, you can think of, like, again, how I mentioned that how a list is a variable that holds a lot of variables in it, a lot of data in it. Well, this is the way we access those individual bits of data. So 0 gets us that very first item. Now it goes from 0, so these slots, these indexes, or indices as I'll call them, these indices go from 0 up to, but not including the length. Sound familiar? Up to, but not including, right? So this has 50 items in it. That means that the slots are labeled 0, 1, 2, 3, 4, all the way up to 49, right? 49 will give us the last thing in there. Actually, it says index out of range. Okay, wait, is it 50 things? Let's ask. We can ask how big something is. This works for strings and for other things. Oh, that's 25. Okay, so it goes from 0 to 24, right? Make sense? So there's 25. So I can then ask 24 to get the last item out of it. 350. Now, as we just saw, if I ask for a slot that doesn't exist, right? Slots 0 through 24, they exist, but as soon as I ask for slot 25, it tells me index error. The index is out of range. That means I asked for a slot. I'm trying to open up a desk drawer that doesn't exist, right? I'm trying to look into a slot that doesn't exist. It's out of bounds. And it gives me an error because essentially the list is a contiguous bit of memory. In other words, it's just a big slice of memory. And it'd be a really bad thing, unless you're a hacker, in which case it's a great thing, to be able to just kind of say, okay, I'm starting here at this piece of memory, and I want to go all the way past this bit of memory to get some random memory, such as like if the passwords are there. So, this is, so here, this is a good thing that it gives us an error. We don't want to read random data. Doesn't matter if it's like 100 or 1,000, it's going to give us an error. Now, one thing that's different about Python than other programming languages is this, though, right? What if we go out of bounds the other way? Now, in other programming languages, that's an issue. That would be an index error. And as you might imagine with me saying in other languages, in Python it is very different. In Python, it does something incredibly useful. It gives me 350. Why did it give me 350? Because that. And if I go to -2, it gives me 1,000. You'll only really use -1, but it's extremely useful. It's shorthand for, let's go through the other direction in this, right? And -1 gets you the last item of the list. It's very useful notation. It is super useful. Can you live without it? 100%. So what will you need to know about negative indexes for the exam? -1 means the last item on the list. That's it. It's very useful. Very, very, very useful. Why? Because the amount of times I want to do everything but the last item, or get the last item and maybe put it at the beginning, right? Or if I sort a list from smallest to biggest, the biggest thing is going to be at the end. So I want to get the biggest item. Okay, it's very useful. So loan amount 0 gives me the first item. And then country name _name gives me the first country in this chart, which is Azerbaijan. Country 1 will give me El Salvador. Country 2 will give me Bolivia. Let's just go ahead and confirm that for ourselves, right? Because the counting starts at 0. So again, all we've done is just kind of, this data has already kind of been imported for us, okay? Now, I find it's probably going to be more useful if we actually use this data, okay? So let's go ahead and look at some very basic statistics here, or very basic statistics questions. And if you want to go on your own and eventually look at some other more statistics questions, then you can look at the part 2. But I think we're only going to have time to do part 1 today. So, level 1 questions. What is the total amount of money loaned? Right? Now, you'll notice that this code over here is blank. Oh, and it has tests. But one thing that's great about it, okay, loan total, let me go ahead and say loan total is equal to 0. And print country _ names. Let's see. Oh, country name. It should be names because it's a list of things, so it should be plural in my opinion. But anyway, print. Even though country name wasn't defined in this code block, it still recognizes it. And if you read what it says over here, it's automatically included for you in the later code boxes, the later active codes. The way these active code boxes work is that I can create hidden code, and that's essentially what those are. Those variables are included as hidden code. Why? So I can do testing. So because these things, the pass, actual value, expected value, those are written in Python. Those tests are actually written in Python. I can show you later in the semester how those how your homeworks are programmed and tested. But anyway, point being is that it makes our code fairly clean. Okay, so what we want to do here for this first question is we want to compute the total amount of money loaned and store it in a variable loan total. Okay, so I create a loan total equals 0, and it says, hey, you need a total loan variable. Fail, and it's saying you gave us a loan total had 0, right? Because it did. And what we're looking for is this answer. That will be, if we get this answer, this will be the, this is what it is added up. Okay? And then it says you may not use sum. So the notes here often are hints. You may not use sum. So one thing we could normally do is use, a very useful thing for later on in the semester is to do loan total is equal to, and what are those numbers stored in? Those numbers are stored in loan amount. Sum loan underscore amount. But for this assignment, it's saying don't pretend that this doesn't exist, this thing that answers your question, the question in one line. Notice it did answer the question, but it says you may not use sum. What sum does is that it does exactly what it says on the tin. It takes a list of numbers and adds them all together. Very useful function, right? It's because it's just such a common operation. So instead, we're going to have to do this manually using an accumulator, right? Loan total is equal to 0. So to use an accumulator, what do? We use a for loop. We use a for loop. Now, in this case, this is the type of for loop where we go over every single thing in a list. So we've gone with for blank in range, right? And this would do a for loop 5 times, right? Then we could do for I in range 5, which says this will run 5 times, and the variable is from 0 up to but not including 5, right? So we have a value, this runs 5 times because we have 5 separate values, right? So that's the second form we learned. Now this other form is for thing in collection, right? For thing in collection of things. In this case, loan amount. And it's extremely useful. For num, let's call it num, in loan amount. Let's go ahead and just print that out, even though that's not going to give us to the answer. For num in loan amount, print the number. Now num here is a variable, right? So we run it. Why is it telling me Bolivia? Where did I put? Okay. I know why it's telling me Bolivia, because it's running this code. Very clever. Okay. So there we go. So loan total is equal to 0. For num in loan amount, print that number. And it does. It prints out 1250, 500, 1450, 200, which is the first 4 numbers, and then it goes on and on, right? So for number in loan amount, print the number. So number here just automatically grabs the first item, then the second item. It grabs index 0, then index 1, then index 2, and index 3. In other programming languages, you have to, you basically create the indexes, and you have to manually grab each item out. But I like what Python does. It says, no. Most of the time, you don't care about the indexes. The vast majority of the time, you want the things in the list. So why don't we just give you the ability to do that? For each number in loan amount. That's what it's saying. That's why this kind of loop is called a for each loop. It's the only type of loop that Python has, but the for each loop does exist in Java and a lot of other modern programming languages. All right, so here take a couple minutes, if you haven't already, to finish the question, right? We want it, loan amount, to finish the accumulator. We want the loan amount to have the sum of all the numbers. Okay? And hit the pause button. That's all. And I do go over the answers. So, for number and loan amount, so let's refresh on how to do a running sum. So, for number in loan amount, loan underscore total plus equals num, which is shorthand for this. Loan underscore total plus num, right? Take what's currently in the loan total, add the current number to it, and store it in loan total. That's fine that we're storing it in the same place that we were getting our value from. That just simply updates that amount. And then we could ostensibly print. We don't need to just for this problem to succeed, but we always like having a visual confirmation. Okay. I'm not logged in, really? I could have sworn. Well, let's go ahead and then log out and then log back in. Log out. Log in. It's so weird that it says I was logged out. Then go back to this page. Okay. And then go back over here and zoom back in. Hit share. Boom. Great. Okay. Compute the average amount of money loaned and stored in the variable loan average. Now, for here, this builds on the previous one. So how do we compute an average? An average is done by doing two things, right? What are those two things? It's a fraction. The top of the fraction is the total amount of all the things you're trying to average together, right? So in this case, to figure out what you're trying to do is find the average amount of money loaned. So the top of the fraction is all the money loaned together. We've already figured out that sum. We've already done that bit with this for loop. The bottom of that is, the bottom of the fraction for an average is the number of things that you've added together, right? So that's how you calculate an average. It's the total of the things divided by how many things you totaled together. Okay. So for this one, we can do that with a very simple kind of thing. So we take loan average, right? As I said, as a fraction. Loan average is equal to, the top of the fraction is loan total, the amount of things we've added together, and we've already computed that, right? Divided by how many things we added together. So there's two ways we can figure that out. The first is to remember, well, if there's 25 things in the list, right, then I divide by that amount. But what if loan total is different? Well, so you don't hard code it. You use the len keyword to figure out how big that is, right? Len, loan, amount. How many things were in there is the length. Length works on strings, it works on lists, right? The other way is like, what if I forgot? What if I forgot that length exists on an exam? That'd be rather unfortunate, but there's always a way around. But there's always a way around that because length is fairly straightforward to calculate yourself. Num things, right? How many things there are is equal to 0. For each number we read, we add that number to loan total, and then we say, okay, the number of things I've added is equal to the number of things I've added plus one more thing, right? So you could manually count it out yourself if you needed to. Notice the difference between these two statements. This is saying, add up all the things I'm reading, and this second one is saying, each time I read something, add one. In other words, mark down that I've read something. Make sense? Run it to confirm that it works, and I'm not just making stuff up. We're going to go ahead and comment that out, comment this out, comment, and then what I'll do is I will instead comment this out. copy this. Don't worry, I'm giving it all to you, so. And then I'll give you the preferred way, which is to do length of loan amount. And then hit the share button. Boop. And you get that code by reloading your page, as long as you're logged in. All right. Number 3. Okay, store the minimum loan in min loan, and the amount of the maximum loan in max loan. Honestly, this would have been so much better had they said store the amount of the smallest loan in min loan and store the amount of the biggest loan in max loan. Then store the name of the country that received the largest loan in max country and the smallest loan in min country. Hint, max and min are built-in Python functions. That's useful, okay. This one actually involves us to be fairly familiar with the way lists work in Python, okay. So just a quick rundown of, idle. Okay, just a quick rundown of the way this works. Okay, right, so suppose I have a list, L is equal to, because I always like to go over these things, 1, 2, 3, 4, 5. Let's go ahead and then put 6, 7 over here, so fine, it's fine. Right, doesn't matter in other words, it doesn't matter what order it is. If I ask for the max of L, it will tell me, whoops, okay, yuck, okay. So if I ask for the max of L, it will tell me that 7 is the max. And if I ask for the min of L, it's going to tell me the min is 1. Let's print out L here so we have a good reference for it for the next part. Okay? So you can use max and min to find the biggest and smallest things in a list. But how do we find what countries those go to? Okay? One other thing we can use is something called index. I believe it's called index. We'll find out very quickly. It's either index or index of. Yep, it's index. Index, what that does is given a thing in the list, it's going to tell you where to find it in the list. So for instance, if I tell it 7, it's going to give me 1. Why? Because index 0, index 1. That's where 7 is. It's maybe a bit easier to see with this. L is equal to the list. Actually, let's go with S for string. Let's go with the string hello space world. Okay? Standard string that we use a lot. Now remember what I said about these things that lists and strings work exactly the same? Max S. Least surprising behavior, W. Why? Because that's the biggest letter, so to speak. From A to Z, right? A is the smallest letter, Z would be the biggest. There's an entire chart we'll get into later that you don't need to memorize or even note for an exam, just simply know that it exists for when you come into things like this. So max of S, min of S now, what's the smallest thing in hello world? It's actually the space that has a lower value than everything else. Why? Because ASCII, that's why. ASCII. It's a chart for these kind of codes. It's fine. Every one of these has a value. So if I say, what is the value of H? It's going to tell me that H's value is 104. That's how it's figuring these out. I would be 105. Don't need to know about that for right now. Just, we can use max and minimum. Now the reason I went over to letters is because now I'm going to ask it where letters are, and that's a lot easier to figure out with strings, right? Because you're not going to be confused by me saying 7's at index 1, 2's at index 3, right? Instead, we now have H is at index 0, E is at index 1. Right? You can do it the same way, right? H is at index 0. They work exactly the same. So if I say, what's the index of E? Dang it. What did I do wrong? Yes?
E was undefined.
E was undefined. What did I mean to do?
Did you define E?
Need to give the literal E.
Yeah.
There you go. It's in index 1. Okay? If I ask it for something that doesn't exist, like index X, it says nothing. S dot index Z, nothing, right? Because it doesn't exist. It's going to give me an error because it doesn't exist in there, right? Okay? So S has no X, no Z. If I went for A, it wouldn't have that. Now, what if I looked for index L? It gives me 2. Now, if you notice, Hello World has 3 L's in it. What it does is that it gives me the value, it gives me the index of the very first one. Make sense? It gives me the value, the index where I find the very first one. Because that's typical. Now there's a way to modify index that gives you ones that you don't, that later, but that's not necessary. So now we have all the tools we need for this problem. Okay, min loan, very easy to find out. Min underscore loan is min loan underscore amount. Make sense? Okay, now we need to get the max amount. Max loan, one amount. That gives us 2. Still have Bolivia up here. Let's get rid of this one. Okay, it's giving me Bolivia because I need to save that. There we go. Okay, min. So, now it's saying, okay, so you've got your min loan, which is the smallest one is 100, and you've got your max loan, which is 1,800. That's the biggest loan. So which country corresponds to those? Okay, and we could look up in the chart and see that, right? 100 corresponds to the Philippines. That got the smallest loan. And 1,800 was Georgia, the country, not the state, got the largest loan there. But how do we figure those out? Well, what we have to do, if we think about it for just a second, is we basically have to figure out how to get from here to here. And how do you do that? With the index operation. You see, 1,800 is at some index. And we know that that's going to be the same index that George is at. So you need to use the index operator. Okay? So give that a second, and then I will run through the code. So go ahead and try it yourself. It's not to make one, or rather 2, mega big lines that solve your issue. You can do one mega big line that answers the question, but it gets painful then, right? We're trying to find, so the countries are stored in country name, right? And we want to figure out what the country with the largest loan is, okay? So I feel like, weirdly enough, it makes the most sense to kind of work backwards sometimes with this one. Okay? So what is the country that has the largest loan? Well, it's found at some index I got to figure out. I'm going to go ahead and create a variable that I haven't defined yet called max index. Right? The index of the biggest loan is going to be found at max index. Make sense? Oh, remember to use subscript notation. And to throw random incorrect characters into your variable name. That'll do it. So this is where the biggest loan amount is. Okay? So how do I figure out what the max index is? Well, we know what the loan amount is. So what we do is we say, okay, max underscore index is equal to max index is equal to loan underscore amount dot index. That's how we get the index of something of some value. Max index. And then max underscore loan. So this says, hey, max loan, I want to know what index that you can find that in inside loan amount. Or another way to look at that, let's take loan amount. I want to find the index of this specific value, max loan. Tell me where that comes up. And I'm going to store that in max index. And then I'm going to take that index and ask what country corresponds to that index, and I'm going to store it in max country. Why max country? That's what it says to store it in. Save it, run it, it says, hey, you didn't do that for min country. That's fine. I'm going to say min country is equal to whatever. Save and run. And it says, okay, and so we did it correctly using using the index function here. Okay? So what I did was I broke it up into two steps. I said, let's find the index of where that of this loan amount, right? And then we're going to look at what country corresponds to that index. Okay? Because remember, everything in every single row will have the same index. Right? Everything that's in the same row over here will have the same index. Okay? Let's see. So now to get the Philippines, right? What I was saying about so I'm going to do what I said not to do, but this may have been what you were trying to do. For the Philippines, that would be min underscore country is equal to, well, that's the country, the name of the country is going to be found in country name, and I want to look for a specific country in there. What country what's the index? Well, it's the index of the minimum loan. Minimum loan is found in loan amount dot index min loan. This looks awful, right? Like, even I've been coding for a while and I still think this looks awful to do it like that, right? Because you've got this nested statement, which normally isn't necessarily too bad, right? Nesting too deep, one variable inside another, having an expression in the index isn't the worst thing in the world. But I think what the really jarring thing here that makes it so unappealing and makes it look really complex is the fact that we're mixing braces and, we're mixing our brackets and our parentheses, right? That's just not, ugh. So that's why a lot of times it's best to, even though it takes a bit longer to write, it's okay to break things up into these steps like this. It's okay to break it up like this. It's okay to break it up, your variables up so that your code is easier to read. Compute the number of average lenders per loan and store it in the variable average lenders. Okay? This one, take a moment to do it by yourself. My only hint is how do you know what those are? Well, the average lenders, well, here's how you, well, here is the lenders total for each loan. So so your answer is going to involve this. So go ahead and take a minute to do this. And I'm just keep copying this here so you can have the variable for reference. All right, so a lot of you have fallen for, if you're still working on this one, have fallen for the one of the pitfalls, which is things are a lot easier sometimes than they appear to be, and it's super easy to overcomplicate things. The average number of lenders per loan can be computed exactly the same way as computing the number of the average amount of money loaned. It's an average. And it's an average over a single column. So we just solve it the same way. So we say something, so we just simply wants to know average lenders. So what we'll do here is we do what we did previously. We do we have a running sum, so I'll just call it total, equal to 0. For thing. So for lenders in num lenders total, for how many, so for each loan, how many lenders were there? Total is equal to total plus lenders. That gets you how many total lenders there were. So we would say, so in that case, the answer is average lenders, unless I'm horribly misreading this one, is equal to the total divided by the the length of num lenders underscore total. Yeah, like I said, very similar to an earlier problem. All we're doing here is adding up all the lenders and saying, okay, for each loan, how many lenders were there? Throw that all together into a pile. Okay, how many total loans were there? Divide by that amount. So, compute the total number of loans made to the Philippines and store it in the variable Philippines count. Oh, so the fun thing about this one, okay, is actually that this is a ridiculously short one, I believe. Because, again, it's a matter of knowing some use cases of Python. Let's see, S. I believe the function to know in this one, so there's a couple ways we could do this. We could just simply, iterate through every single index and ask, okay, if this index corresponds to the Philippines, increase the Philippines count. Or we could do what I'm about to do and ask s.count of L, and it tells me 3. So given a collection of things, the .count function gives you how many things there were. So for instance, this now reduces the hardest part of this to spelling Philippines correctly. Okay, Philip, 2 P's, 1 L, 2 P's in a row, 1 L. Philippines underscore count is equal to, okay, and then country name is the variable, country underscore name dot count, the number times PH, got to be capital here, by the way, for this one, because it's capitalized in the names of the countries. Oh, sorry. The names of the country are capitalized in the data set. Philippines. Right, it says you should use a list method to count, which I did. One line answers the question. Now, what I mean by that, again, Java, Python, C, all the programming languages are case sensitive, meaning they care about capitalization. Here, if I look for Philippines lowercase, it's going to not count any of them because it says, oh, well, I didn't count any lowercase Philippines. Capital P Philippines, yeah, count that. Okay. And the last problem for the day. For each unique country name, okay, when I see for each, that tells me that maybe there's a for loop involved. For each unique country name, oh look, there's a variable there for unique countries. Print a line that shows the name of the country and then the number of loans made in that country like this. Guatemala, 1. Okay? So go ahead and try that. Now remember, so you're going to need a for loop and you're going to need the print statement. And remember, if I want to print out 2 things, I just simply do print thing 1, comma, thing 2. Oh, that brings me back to the days of Dr. Seuss. Okay. So this will be the last problem we try for the day. So try this one. Then I will give you the answer, and then you'll be free to go. I mean, technically, I can't hold anybody in this class as you've discovered, but it's useful for you to try this last problem. You got it?
Oh, no.
Oh.
I was just trying to speak to myself. That's why. I'll figure this out.
So if you haven't gotten there yet, what you want to do is write a for loop that for each country gives the count of that country. You can count for each of these unique country names, count how many times that occurs in country name using the .count function. All right. So here we go. So here we have a list of unique countries, and what it's asking for is, for each of these unique countries, print a line that shows the name of the country and then the number of loans made in that country. Okay. So again, when we do problems and problems are too big, focus on what you can do. Like, I'm not sure how to print out the one, but I can print out each name. For name in unique countries, and you can use whatever variable name you wanted there. You could have been country, could have been name. I did name because it was 4 letters long. 4 letters is like a perfect length for a variable. Okay, for name in unique countries. Print, okay, name. Okay, it tells, and it says that wasn't right, but at least now I've got all these things. So what I want to do now is I want this space and then the number of times this appears. Okay, so, oh, okay, that's 2 things, and we know how to print 2 things. So num loans is equal to, we'll just do 0 for right now. It's not right, but then I can at least get it in the right format, right? Num loans. Guatemala, 0. Paraguay, 0. Tajikistan, 0. Kenya, 0. Azerbaijan, 0. Right? That's not the correct answer, but it's, now we're getting somewhere, right? Now I need to figure out what I need to put here so that I get the right answer rather than the 0. Okay? And what I need to put there is how many loans were made to that country. Well, how many loans were made to that country? Well, I know what country a loan was made to by looking at the country name field. Okay? So if I want to know how many loans were made to that country, I need to count how many times that occurred in country name. Country name, so for instance, if I want to count how many loans were made to Azerbaijan, I would say 1, well, just 1 apparently. What about Bolivia? 1, 2 to Bolivia. So, and we learned in the previous one that if I want to count the number of times something appears, I use the .count function. So if I want to know how many times that name appears, well, country underscore name dot count, so I want to count how many times it appears. Now the name, and I can't just use Guatemala or Paraguay, because that would just, if I just put Guatemala here, that would be, well, for every country, give me the number of times Guatemala appeared, which is 1. That's not what I want. It needs to change each time. And there's one variable that's going to change. In the first time this loop runs, name is going to be Guatemala. The second time, name is going to be Paraguay. The third time, name is going to be Tajikistan. So what I do is I put name over here. Right, for name in unique countries. Count the number of times that occurred in country name. Or another way to look at that, go into country name and count how many times that name occurred. Store it in the number of loans. Print out the pair, name, and the number of loans. Guatemala 1, Paraguay 2, Tajikistan 1. And there we go. And that's, now, for the exam, if you take a look at the practice exam, you'll see there's not really many questions of this type, where we iterate over a loop and ask you to do running sums and stuff like that. That will be more in the domain of exam 2. A lot of times where we're looking at is for loops and turtles. So this is just to hammer in how this works. If you're concerned about what's going to be on the exam, take a look at the announcement I sent out. It should have come in your email. And look at the code. Try the questions. And especially if you need that extra practice, then go to that extra practice section I put in the back. These are extra challenging questions that are meant to help you learn. Have a great weekend.